Hello and welcome to another video on the AQA A-Level Paper 1 Summer 2026 Skeleton Code and Eater. I've done 4 previous videos. You might want to have a look at them first. Hopefully you have, or you've got a good understanding of how the code works. I've done some changes in those videos, or demonstrated some changes which you might want to have a look at, which has an impact on this. What I intend to do on this video is, well, I've basically made some changes to the code. I've introduced a soldier ant and an anteater an anteater which goes around eating ants. It's kind of made it a bit more interesting, the game. I've made a few other changes to it. So first of all, what I'm going to do is display the game as it is, or the simulation. So I'm going to select simulation 1. I'll display the overall details. First things first, I've modified the code so that we create 50 ants, not just 5 for simulation 1. Thought that would make it a bit more interesting. And also, in a previous video, I've changed the display with the get details method to make it 2-dimensional, so you can see a bit better what's going on, how the ants are moving about in a 2-dimensional way, rather than the big long list that you get with the code. That's an easy change. You can just cut and paste the code that I've created to do that. Whether that will be an exam question, they may ask you to make some changes to how the display is made, so it's worth having a look at that code to try and see if you can figure it out. But I would just cut and paste that code in. I've used a little bit of AI to cheat as I've done some of this code, just to save time really. But it would help to sort of analyse that code when you go in the exam. And it would help to sort of do these changes that I've done in order to understand what bits go where. So let's just describe what's going on here. We've got a queen. The nest is always set up at row 2, column 4 here, and in the nest we've got 1 queen, 41 workers, and 8 soldier ants. We've got a food cell here, and we've got a food cell here. This food cell is placed randomly. It looks like in this particular simulation that 3-2 has been selected twice, so it's added the 2 together to get 1,000 in that food, in that cell. We've got the anteater class. Sorry, the anteater here. We've created an anteater class in the program, but the anteater moves around. It always starts in 1,1, and it moves around. So I'm just going to advance that one more stage. The anteater stayed where it is. The workers have moved out from that cell, leaving the queen and 1 soldier ant in there, and the soldiers have also moved about. And a new soldier has been created as part of the nest advanced stage. Okay, it's moved on one more stage. The anteater stayed where it is. It kind of chooses randomly which way to go. If it chooses to go this way, of course it can't, so it's stuck. So no doubt it'll be moving across pretty soon. The workers are on the move. Some food has been found here, and 2 workers and a soldier have found this pile of food here, and this food has gone down a bit, and there are 5 ants there. Okay. You can also see the pheromones in that cell as well, which lead back to the nest. Food's gone down. A few more workers are found there. The anteater hasn't moved again. That food's gone down. Those worker ants have been busy getting that food to take back to the nest. Anteater has still not moved. I'm going to move it on. Worker ant has died. soldier ants have died in battle, so when they come across each other, they do battle, and one of them dies as a result, or both of them actually. So it's told you which one has died there in the battle, and a couple of worker ants have died of natural causes. Anteater has still stayed. Okay, the anteater has moved now to this cell. A couple more battles have taken place between soldier ants. The anteater has moved across here. Again, we've had some more soldier ants. What I should say is that soldier ants only really, in the real ant world, soldier ants only do battle against opposing colonies. I've not put that code in here. They just do battle with each other when they land on the same cell. Another soldier ant died in battle. I'm hoping to demonstrate when the anteater seems to be, oh, there we go. No, we've still not, the anteater has still not found any ants to eat. It's moved into the, oh no, here we go. Oh, it's had 2 queen ants. It's landed in cell 2-4 and had the 2 queens. So that's it for that ant nest really. Anyway, let's move it on. You'll also notice, yeah, the anteater's just not finding the ants at all in this simulation. It does do, and the ants have all died. You'll notice that actually I've not done a 4. When I've pressed 4 to move it on one stage, it also does the display of all details. Okay, let's go through the code without any further ado. I've changed some of these parameters here. That's where I've changed to have 50 ants in simulation 1 to be created. Okay. So here, when we do number 4, which moves the advances the simulation 1 stage, I've inserted this line here, which is the same as this line here. It just saves you pressing 1 after every 4 to see how things have moved on. And I've also put it in here as well, after 5, where you move on multiple stages. Okay. So let's have a look at the soldier ant. I'm going to find the class first, actually. So here we go, class soldier ant. So we've introduced this protected integer for the health. So in standard gameplay, in battles and things, you've got this health idea that the 2 soldier ants do battle against each other. The health of one gets worse before the health of the other, and that one dies. So that's created. That's based on random numbers. So we've got this random number thing going on here. They don't carry food. We've put the type of ant as equal to soldier. That has come from the ant class, the type of ant. The health is this new one that we've got. And the food capacity, well, we've inherited that from the ant class, but we've just set it to 0 because soldier ants don't carry food, and they just do battle. We've got this getter here, get health, which is public, which means it can return to other parts of the program the value of the health, which of course is protected, which means it's only available to this class or any that are inherited from it. We've got the change health here, where we are past a parameter of the change of health. That will be based on the random number generation here, or rather here, and we change the health value. We've got this fight method here of the soldier versus another, and random numbers are generated to diminish the health of the ants as it goes along. There are three possible outcomes of a fight between two ants. One is that one of the ants dies, where we return 2. One is that the other ant dies, so we return 1. I think it's the other way around, actually. Or there's a possibility that that both ants die. Actually, that's this one. So this is the other health. This is the ant, and this is where both ants have both had their health go to less than or equal to 0, in which case 2 is returned and both ants die in battle. Otherwise, we return 99. That shouldn't happen. The soldier ants do what the worker ants do, which is they follow the pheromones around. So we've got this. We've got this choose cell to move to here. This method, and we're looking for preferably cells that have pheromones in them, with the strongest pheromone. Otherwise, we will randomly go to another cell. Okay, so let's see where else we can find that. So that's the end of the soldier class. Let's see where it's played around with. Go to the top of the program, actually. That would be the easiest thing, and find all the occurrences of it. Okay. So when the nest is originally set up, we need to generate some soldier ants. So set up nest at method, 10% chance of creating a soldier ant, 1% chance of creating, well, actually, we always create a queen. We always create one queen, and we then 10% chance of generating a soldier ant, otherwise a 90% chance that we create a worker ant, and we add them to the ants list. Okay. This is the get details. Okay, so the get details is the bit that displays the contents of the nest in the program. You know, option 1, or in my case, option 4 and option 5 after we've done the other actions. So the get details do that. I have added in the soldier ants and the queen ants and the worker ants and the pheromones, all displayed on that board as single letters with the number of workers and queens. So we have to toss them up. We set the queens, workers and soldiers to 0. We go through the ants list. If it's a queen ant, we add 1 to the queen ants. If it's a worker ant, we add 1 to the workers. If it's a soldier ant, we add 1 to the soldiers. Then we add to the parts. We have the parts list that we're totting up on here. The queen, workers and soldiers, and then we join it all together here to create the details. So we're adding it to the details. Okay, here. This minus 16 means that we've got we move over to we're allowing 16 characters for the cell text as we going along. Don't worry too much about that. I don't think you're going to be asked to do major amendments to the get details, but you might be asked to do a better type of display or do something with the display. I don't know. Okay. We've got the soldier combat here, where we're going through the ants list, and if we've got an ant and if the other is a soldier ant and basically if the two ants are in the same location, then there's a fight resulting of it. So we pass over the soldier ant fighting against the other ant, which is passed over. So here, this is where you check the result. If it's a 0, soldier O dies. If it's a 1, soldier A dies. If it's a 2, both ants have died in battle. And I've put these console write lines in to show the result of the battle. Okay, this is where, right, okay, this is the anteater class. We'll come to that in a minute. And then we've got the soldier. Okay, we've pretty much done it. I think that's the lot. There's the fight, movement of soldiers. Yeah, this is the advanced stage, I think, isn't it? So, you've also got in the advanced stage where after the initial setup, every time you move on a stage, you've got this advanced stage method. One of the things that you want to... So ants die and ants are born in this advanced stage. Here, you will need to keep this creating soldiers. I've used slightly different logic here. I've created a 50% chance of a soldier or a worker once you've decided that you're not creating a queen. So there's a 1% of a queen. Otherwise, we're going to 50-50 chance of a worker or a soldier being created. And we add the row and column number of the soldier or worker ant there. Okay. That's it for the soldier. So let's go back up and we'll have a look at the anteater. So we've created a list called anteater. Yeah, so we've got the list anteater there, flat list containing all the cells computed by the row and the column mapping. When we call up when we create the anteater, we give the starting position. So we've created a new anteater, the anteater at position 1, 1. But we can change that to anything we want. So that's done when we're first constructing the simulation. Where this is the get details again, where we're displaying where the anteater is. So I think at the very bottom, it's in there somewhere. So we've got Boolean value, and if the anteater is present in that cell, then we display. Okay. And here it is actually. If has anteaters, then add asterisk E asterisk to the parts list, join all the parts together, and then put that detail on the board. I think I've said previously that -16 means that we're allowing 16 characters for that. This again is the get area details, and this is the get cell details. I think get cell details. So option 3 gives you the ability to see to inspect an individual cell, get a bit more detail, tells you that the anteater is present and is currently the row that it's at. You don't need to display that actually, because you've actually put that in as the parameters. So here we've got the bit where the anteater moves randomly. Now, this is the bit I wanted to talk about. You've got the anteater taken directly or inheriting from the entity class or the superclass. So entity, everything is inheriting from the entity. From the entity, we've got the ant class and the cell class. And from the ant class, you inherit the worker and the queen ant, and so on. We are going to, because the anteater isn't an ant, we're going to inherit directly from the entity. And we are inheriting the row and column from the entity, but we're not adding anything else to it. We've got this method here where the anteater moves randomly. This is very, very basic. It's not following pheromones or anything fancy like that. It's just creating a random number between -1 and 1. It's adding that to the row and the column, and then we're just making sure that it doesn't go beyond the bounds of the grid. So we've got the number of rows, so we're making sure it doesn't go, we're making sure that it's between greater than or equal to 1. So if it was a 0, we wouldn't do this. It wouldn't move. Or it wouldn't move to the left of the row. And likewise, it wouldn't move to the right of the rows if it was greater than the number of rows. Likewise with the column, same logic there. So we're only updating them if they're within the bounds of the grid, or the new value is within the bounds of the grid. Okay. This is the bit where the ants are actually eaten, consumed. The anteater, if there are ants in the cell where where the anteater is, if it's greater than 0, then we say that the anteater has entered the cell. The contents of the feast. This is where we total up the number of ants in the cell that it's moved into. So we're going from ants, A in ants here, which is the cell, Okay, and we're adding up the number of queens, the number of workers, and there's a number of soldiers, and we are going to display how many queens there are, how many worker ants, and how many soldiers there are in this series of 3 right lines. And then we're going to remove all the ants from that cell, because the anteater is very basic. If it finds ants in a cell, it just consumes the lot. It never gets full, never gets hungry, it just eats the ants that are there. We've got this get details here, which is overriding the get details from the entity class, and it just shows where the anteater is. And that's it. I think, let's just check, that's the anteaters. Yeah. What I should have said was I'm going to put a Word document and maybe a copy of this code so that you can have a look at it and play around with it yourself. What is useful here, to conclude with, perhaps I should have said this at the beginning, is that if you're asked to set up a new class, let's find a class that we've class and eater. So you're asked to set up a new class and you're not quite sure of the syntax, just go and find another class and copy it and get the inherited from and to the constructor, and you don't really have to do very much to get 1 or 2 marks there, even if you're not sure. But just cutting and pasting from another part of the program to create the anteater could just be enough to get you a couple of marks and get some, even if you don't get the syntax quite right. For the rest of it, just simply getting that line right might be enough to get you a mark or 2. So always have a go at the questions. Always, do something, and you can plagiarise other parts of the program to do it. So I think that pretty much concludes this video. I'm going to do one more, I think, which I'm going to make some minor changes to that. But for this video, I'll create a link, hopefully, to a Word document which has got all this sort of stuff in it, so you can have a go at doing it yourself. It's a worthwhile exercise to do, even if you would never get a question like this. It would never be this complicated. You've got, I think, 60 minutes to do section D, and something like this would take a couple of hours. So you've got to bear in mind that it's maybe 20 minutes or so for the harder questions, maybe, and 10 minutes perhaps for the easier questions. I don't know exactly, but you'll not get anything like this complicated. But it's a worthwhile exercise just to sort of do something interesting with the code, really. And by adding all these bits in, you do start finding your way around the code a lot better. Okay, bye for now.